Okay, in this lesson we're going to continue with our 3.4 study guide. We've been looking at the sine and cosine law so far in this chapter. We're going to look at the last two examples of the 3.4 study guide. So example 2 says this. It says a regular octagon. So this octagon has all equal sides. With center O is shown. If the distance from O to a vertex of the octagon is 12 centimeters, so if this distance is 12 centimeters, calculate the perimeter of the octagon. So essentially, if I could find out the length of this side, I could then just times it by 8, and I'd have the perimeter of the octagon. So in these problems, there's many ways of doing them. Just start somewhere and do something. So if you ever want to try this on your own, you may want to pause the video and try something on your own. This is one of many ways to do it. I'm just going to represent all of the distances from O to all the vertices, because that might help you picture this problem. So what you might want to notice is that all of these side lengths here are 12 centimeters. So this length here would also be 12 centimeters. Also, if I want to find some of the angles or start finding some of the angles, there's multiple ways of doing this. You could use the sum of polygons from a previous chapter. I'm just going to start here. If we know those all add up to 360, then one of those angles would be 360 divided by 8, and that is 45 degrees. So we know that this angle, for example, I'm just going to focus on this one triangle, is 45 degrees. And if I wanted to find each of these two angles, we know that they're equal to each other. What I could do is 180 degrees of a triangle minus the 45 degree angle we know is 135. And if I divide that by 2, I'll get the two equal angles of 67.5 degrees. That may or may not be helpful. But now we know everything about this triangle except for the one side length that we're asked to find, that pink side length. And maybe I'm just going to call it here, maybe I'll just call it x. Okay, so if we focus on this triangle, what you might want to notice is that at this particular moment, we've got x is opposite 45 degrees, and if we know any side and its opposite angle, which we do, we've got 12 is opposite 67.5, that means we can now use the sine law if we'd like to, and that might be the easiest route to go. So the sine law says this, x over sine 45 is equivalent to some other side length, so 12, a known side length, over its known opposite angle, so 67.5, sine 67.5 degrees. This should take one step. Multiply both sides by sine of 45 degrees. And we know that x is equivalent to that boxed product and quotient. So x is equal to, make sure your calculator's in degree mode, and use your equal sign as much as possible. So 12 divided by sine 67.5. There's my quotient, and now if I times that by sine 45, I get 9.2. So x is 9.2. And as discussed, if I want to find the perimeter of the whole thing, the perimeter is equivalent to 9.2 times 8 sides, and that's going to get me roughly 73.6 centimeters. So there's my answer number 1. Number 2 says this. Number 2 says calculate the area of the octagon, and recall that the area of a triangle is base times height divided by 2. So in this particular problem, what I'm going to do is focus on the area of one of these triangles, maybe the triangle that I already have some lengths or some measurements in, focus on one triangle, and then I could times it by 8. There's other ways, again, of doing this. So I'm going to call this my base. We know that that's 9.2 centimeters. We've already done that. And the height of this triangle is 90 degrees to the height. So I'm going to call this the height. So in this particular case, what I can do is focus on a smaller triangle. So if I want the area of the entire triangle, I'm going to focus on the triangle that's inside that triangle. So this small right triangle right here, and I can focus on some opposites. Maybe I'll highlight them in different colors. We have that 90 degrees is opposite 12 centimeters in that pink highlighted triangle. And we also have that the height is opposite 67.5. That says to me we can use the sine law. So for number 2, if I want to find out the height, I'll just call the height h, be h over sine 67.5 is equivalent to some other side length, which is 12 over sine 90. So again, this should take one step. So this is times sine 67.5. So h is equivalent to, the height is equivalent to 12 divided by sine 90, which is still 12, and then times that by sine 67.5. If I'm going too quickly, you may want to look back at a sine law lesson. So it's 11.1 height. So that means that the area of one triangle is base, which is 9.2, right here, times height, divided by 2. So 9.2 times roughly 11.1 divided by 2 is 51.06. That's per triangle. So I have to take that, because there's 8 triangles, and times it by 8, and I would get my answer. So the area is 408.5 roughly. So 408.5 centimeters squared. Again, there's multiple other ways to get a similar answer. Let's look at the last problem. It says 2 fires are 45 kilometers apart. So focusing on this picture right now. Fire A is directly north, so here's a helicopter. Fire A is directly north of a helicopter, and fire B is directly south of the same helicopter. The angle of depression from the helicopter to fire A is 15 degrees. If the helicopter is 30 kilometers away from fire A, how far away is the helicopter from fire B? That's the first question. And what is the angle of depression from the helicopter to fire B to the nearest degree? So there's actually 2 questions here. Unfortunately, this picture here won't do it, because we can't create a triangle if the helicopter is in line with the fires. So what you want to do is picture it from the side, because then we can indicate the angle of depression. So I'm going to rather look at this picture right here. So picture this as being directly north of the helicopter, this is directly south. But it does state that the angle of depression from the helicopter and this is angle of depression, is the angle down from the helicopter to fire A, is 15 degrees. And let's just complete this triangle. So this is 15 degrees as well. I'll tell you why in a second, and this is 30 kilometers. So the reason that I knew that this was 15 degrees was here, right here, is because we have 2 parallel lines, the bottom line and the top line, which means that these 2 angles are alternate interior angles, and they must be equal to each other. So within this triangle at the moment, what I've got is 2 side lengths and the contained angle. And what we're being asked to find is, I'm just going to label it with an X, is the distance the helicopter is away from fire B. And we're going to use, because we've got 2 sides and a contained angle, we're going to use the cosine law. I'm just going to move this picture for the moment so we can create some extra space here. So, cosine law, a squared is equal to b squared plus c squared minus the product of 2 times b times c times the cosine of a. In this particular question, 15 degrees is going to be replacing capital A, and x will replace lowercase a, and it doesn't matter where the sides 30 and 45 go as long as they replace sides b and c from the cosine law. So we have here x squared is equivalent to 30 squared plus 45 squared minus the product of 2 times 30 times 45 times the cosine of 15 degrees. Now if we find out those 3 products first, 30 squared is equivalent to 900, 45 squared is equivalent to 2025, and the product 2 times 30 times 45 times the cosine of 15, that's equivalent to 2608. And we're left with x squared is equivalent to 900 plus 2025 minus 2608. We have 317. So that means that x is equivalent to the square root of that value. So square root of 317, roughly 17, nearest tenth of a kilometer, 17.8 kilometers. So this distance here, which we add information as we find it to the triangle, is 17.8 kilometers. So part B says, what's the angle of depression from the helicopter to fire B? So essentially, this angle of depression is equivalent to this angle right here. So let me label this with a theta. These are both the same angle, but I want to focus on the triangle. So if I can find this angle, I've got the angle of depression. In this particular case, we do have an angle on its opposite side. We've got 15 being opposite to 17.8. And now we're trying to find out, it says 30 is opposite that angle. So we can use the sine law. The sine law would say this: sine theta over its opposite side 30 is equivalent to sine of some other angle. In this particular case, it's sine 15 over its opposite side 17.8. This will take 2 steps to solve. Multiply both sides by 30. So we'll have sine theta is equivalent to whatever this boxed part is. And again, hit equals as often as possible. So try this on your own. Sine 15, hit equals. Divide by 17.8, hit equals. Times by 30, hit equals. So sine theta is equivalent to 0.436, 0.436, 211, etc., etc. So the last step is to take the sine inverse. Because when we're solving for angles, we're always taking the inverse as our last step. So we'll get that angle is equivalent to roughly 26 degrees. And that's the answer. So this angle here is roughly 26 degrees. Finally, the key ideas, really briefly. When you're solving problems involving triangles, again, they're difficult. Try many things. Sketch a diagram as accurately as possible. You don't know if your answer looks accurate. That way you can see if your answer is reasonable. And there's lots of things you could try to do. You may use the sine law. You may use the cosine law. Maybe you'll use the fact that sum of angles in a triangle equal 180 degrees. You may be using the Pythagorean relationship, which you could actually use the sine law instead. And you might be using SOHCAHTOA. However, the sine law or cosine law can replace SOHCAHTOA now.